The next DPP is DPP number 6, geometry, and second DPP of geometry. Question number 1 is, in a triangle ABC, BE and CF are medians. BE is equal to 9 cm, CF is equal to 12 cm. Now if BE is perpendicular to CF, then we have to find the area of triangle ABC in square centimeter. The solution for this question can be given as, first of all, let us draw a figure for the given problem. A, B, C, B, E and CF are medians. So that must be centroid. The angle is given to us as 90 degree. As B is median, so it divides AC into two equal parts. Also, F divides AB into equal parts. Now, as we know that centroid divides median in the ratio of 2:1, so that must probably be 4 and that must be 8. Now that should be 6 and that should be 3. Now as we know that G is centroid, so we can say that BG upon GE is equal to 2:1. So we have written that AG is equal to 6 and GE is equal to, BG is equal to 6 and GE is equal to 3. Similarly, CG is equal to 8 and GF is equal to 4. Now area of triangle ABC will be equal to 3 times area of triangle BGC. Now as we can see that area of triangle BGC is equal to half into base into height, that means half into 6 into 8, that is 24. So area of triangle ABC will be given as 3 into 24, that is 72 square centimeter. That is our answer. Moving to our next question, question number 2, that is given to us as 9 lines drawn parallel to the base of a triangle divide the other two sides into 10 equal parts and the area into 10 distinct parts. Now if the area of the largest of these parts is 1997 square centimeters, then find the area of the triangle. Find the area of the triangle. To solve the above question, let us have, let B and H be the base and height of the triangle respectively. Now the largest part is a trapezium with sides B and 9 by 10 B and height h by 10. This is a triangle. The parallel lines are drawn in this way, which divides the triangle. Now we are talking about this trapezium. The height of this trapezium will be equal to h upon 10. The height of this trapezium will be equal to h upon 10. The sides, this side will be equal to 9 by 10 B, 9 by 10 part of base, and this is base, it is B. Now as we can see that the area of the largest part, that is the trapezium, will be given by half into h plus 9 by 10 B, half into sum of parallel sides into distance between them, this is B. Now half of B plus 9 by 10 of B is given to us according to question 1997. So area of the triangle from here, as we know that the area of the triangle may be given as area of the triangle from here, as we know that area of the triangle may be given as half into base into height, that is half BH. So the area will be equal to 199,700 whole upon 19 centimeter square. That is our answer. Next question, question number 3, that is given to us. Triangle ABC is isosceles with base AC. Points P and Q are respectively in CB and AB such that AC is equal to AP is equal to AQ is equal to AC is equal to AP is equal to PQ is equal to QB. Now we have to show that the measure of angle B is equal to 25 and a 5 by 7 degree. Let us try to solve the given question. To solve the above question, first of all let us draw a figure to understand what is given to us. Let it be point A, this point B, B, and this point be C. Let it be point P and this point be Q. Now join PQ and join A to P also. Now from here, as it is given to us that AC is equal to AP, that means this AC is equal to this AP is equal to this PQ and is equal to this QB. Now let the angle B that we have to find be alpha. So in triangle BQP, as we can see that BQ is equal to QP, so the opposite angles will also be equal, so angle P will also be equal to alpha. Now as angle B and angle P is equal to alpha, so the exterior angle, that is angle AQP, will be given as 2 alpha, sum of opposite interior angles. Now in triangle QPA, if angle Q is equal to 2 alpha, then angle A will also be equal to 2 alpha. Okay, again opposite angles of equal sides. Now if it is 2 alpha and 2 alpha, then the remaining angle of the triangle AQP will be given as 180 degree minus 4 alpha. Okay, now this is a line, so this is a linear pair. This is a linear pair. Then this angle will be given as 180 minus sum of both angles, that means 3 alpha. Now if the angle APC is equal to 3 alpha, then angle C will also be equal to 3 alpha. Okay, but we have also given that ABC is an isosceles triangle. So if ABC is an isosceles triangle, then angle A will be equal to angle C. So this is 3 alpha, angle C is equal to 3 alpha. So this will, angle A will also equal to 3 alpha, and as this is 2 alpha, so this will all equal to alpha. Now as we know that by the angle sum property that the sum of all the three angles of a triangle is 180 degree, so we can say that angle A plus angle B plus angle C is equal to 180 degree. From here we have that 3 alpha plus alpha plus 3 alpha is equal to 180 degree, or we can say that 7 alpha is equal to 180 degree, or alpha is equal to 180 upon 7, that is equal to 25 into 5 by 7 degree, hence proved. Next, question number 4, and question number 4 is find the ratio of the area of the equilateral triangle. Find the ratio of the area of the equilateral triangle inscribed in a circle, inscribed in a circle to that of a regular hexagon inscribed in the same circle. Okay, let us try to solve the above question. The figure for the given question may be drawn as this will be radius of this equilateral triangle of the side A. Now the same circle with radius R, let it be center. So this length will be equal to radius R, this will be equal to R. Now as we know that the regular hexagon, the angle is equal to 120 degree, this equal angle will be 60 degree, and so this will be an equilateral triangle. To solve the above question, let us have if R is the radius of the circle and A is the side of the equilateral triangle, inscribed therein, then we have n is equal to 2 by 3 into 2 by 3 into root 3 by 2 A, that is equal to A by root 3, or R. Or from here we may have that A is equal to root 3R. So the area of the equilateral triangle will be equal to root 3 by 4 into A square, that means root 3R whole square, that would be given as 3 root 3 upon 4 into R. Now let us talk about the regular hexagon. The regular hexagon inscribed in the circle is made up of 6 equilateral triangles with side same capital R. So its area will be given as 6 into area of one equilateral triangle of side R, that is root 3 by 4 R square, that would be given as 3 root 3 upon 2 R square. So the required ratio is 3 root 3 by 4 into R square is to 3 root 3 by 2 to R square, that is 1 is to 2, that is our answer. Let us move to our next question. Question number 5, that is given as 3 circles touch each other externally and all the 3 circles touch a line. Now if two of the circles are equal and the third has radius 4 cm, then find the radius of the equal circles. Let us try to solve the above question by two different methods. Let us have a solution by first method. To have this, first of all let us draw a figure to understand the question. let the point be D, let the point be C, let the center be A, let the center be B, let this be AB, the center of this be O, that will be AB, OB, and that would be OA. Now let the point be E, let the point be M, join O to M. Now if the radius is X, then it would also be X, and it would also be X. It would be 4X, it would be 4. Now let the point be T. Okay. Now we have assumed that the radius of the equal circles is X. Now as we can see that DC and ME, DC and ME are direct common tangents to both circles. Now all three circles touch DC as it is given in the question. Now it is also given that circles with centers A and B are equal. So AO will be equal to OB will be equal to the sum of the radius of both the circles, that is x plus 4. Now since ME bisect AB, so AM is equal to MB. Hence we can say that OM is the common tangent of equal circles touching at M point. Also we have that AD is equal to BC. Now since DC is the tangent and AD and BC are perpendicular to DC, hence we can say that AD is parallel to BC and also AD is equal to BC. So we can say that ADBC is a rectangle. Now again we could see that MBCE is a square, as we have given that ME is parallel to BC, MB is parallel to EC, and ME is parallel to BC. Now in triangle OMA, as it is a right angle triangle, so by Pythagoras theorem we could see that OM square plus MA square is equal to OA square. But as we could see that OM is equal to ME minus EO, that is x minus 4, and EO is equal to 4 is given. So AO will be equal to x plus 4 and AM will be equal to x. Thus by substituting the values we would have x minus 4 whole square plus x square is equal to x plus 4 whole square, that is x square minus 8x plus 16 plus x square is equal to x square plus 8x plus 16. From here we would have that the value of x is equal to 16. The given question may be solved by another method, that is, let us call it method second. Now as we can see from the above figure that the length of the common tangent DC is given by 2 root AB, that is 2 root x square, that is 2x. Now length of common tangent EC will be equal to 2 root BC, that is 2 root x into 4, that is 4 root x. Also length of common tangent DE will also be given as 2 square root of 4x, that is 4 root x. Now DE plus EC, that is 4 root x plus 4 root x, is equal to 2x. Okay, that is equal to DC. So from here we would have 8 root x is equal to 2x. From here we would have 4 root x is equal to x, or we may say that root x is equal to 4, or from here we would have x is equal to 16 centimeter. That is our answer.